My name is Ben Greisler. I am a consultant. Unlike a lot of people here, I'm not in charge full-time of one particular environment. Typically what I'll do is I'll come in and I'll help people like you or people in business or whatever the organization happens to be to try to figure out problems that they might have in an area that maybe they're not fully aware of all the pieces of, just because we can't know everything. So if we find an area where I know something and I can help them, great. Sometimes they're really good, because I'll be honest with you, a lot of times when I do work with like higher ed groups, I am blown away by the knowledge in the higher ed groups. I really am. Because you've got systems that you put together, you've got systems that you've got deep, deep knowledge of, and I always love working with you because I come out learning a lot from it. So I really appreciate that. But sometimes you just don't have enough time. So I come in and I can help. It's not an advertisement for me, but I'm getting to a point. And I'll try not to look like Bernie Sanders too much, the hands. I'm going to lose my hair well before it goes white. The thing, though, that I know is not DNS itself. I'm not going to stand in front of you and tell you I am Cricket Lou. I taught him everything he knows about DNS. So who knows who Cricket Lou is? Okay, and who?
Literally the book.
Literally the book. Cricket Lou and some other guy that no one ever remembers, because he doesn't have as cool of a name like Cricket Lou, they wrote a book about DNS, and it's appropriately called DNS and Bind, or Bind in DNS. And it is a book that I recommend. If you don't own a copy of it, buy it. Get it. Read the first chapter. It will be entertaining. Read the second chapter. It will be informative. Do not go past the second chapter until you need to. It will put you to sleep faster than anything else you've ever laid eyes on. But when you are ready for that information, it will be sitting there, you will understand it, and you'll be able to get use out of the book. Just don't sit down and try to read the whole thing. Ridiculous to do it that way. Okay, so why am I standing in front of you? Well, I've been working with a lot of Apple stuff for a very long time, and I've done a lot of integration work where I need to make Apple technologies work with everybody else's stuff, and there's one common thread across all of this, and that is if you've got broken DNS, it all goes to hell. And if I had a dime for every time I heard, well, it's not broken because my PCs work, as I'm trying to do maybe some Apple stuff. Well, that usually means that I have to sit and explain name resolution to the system administrator I'm working with. Anybody kind of understand where I'm getting at? That's because Windows and OS X don't necessarily use the same mechanisms to achieve the same results. You know, there are different ways of getting the information. All right. So what I have become very good at is figuring out when systems are broken. And I've become very good at making the DNS work well enough to make their systems work. And sometimes I come out looking like a complete and total wizard. And at those times I go, wow, it's not because I'm really, really smart at this. It's because they've been relying on other systems that just, they click a button, things tend to work, but when things get complicated, they don't know enough. And I'm not saying that they're not smart people. They just haven't had to learn the DNS piece. So we're going to talk a little bit about it. All right, agenda. We don't have a whole lot of time. I've already spent 5 minutes doing this introduction piece. We're going to keep the actual I should say the lecture portion, pretty short. And I'll also be very, very upfront that I am terrible at slide decks. Hate them. Don't like them at all. But they're useful in these situations, so I have some. So can anybody guess how many slides I have in my deck?
We're looking at 13.
All right. Well, so one thing, I did bring bribes with me. So the person who comes closest without going over gets one of these OS X Server 5.0 books, co-written by myself and Eric Dreyer. And there is a section on DNS in here. If there wasn't, I wouldn't bring it. All right, so how many slides total? 10. Who said 15? Did anybody say 16? No. You guys are too slow. You get the book. Do you have one already? No. I do now. There you go. Thanks. All right, so that's the first bribe. We got 4 more. All right. So, but really what's important is we're going to be talking about real life experience here, and that's why I want to keep everything really, really short. So the first part, we got the review, but then we're going to go back. We're going to talk about real life stuff. We're going to talk about a couple of things about, well, I had everything planned out 2 weeks ago, what I was going to do. I had it tucked away in my brain, had everything laid out. Great, wonderful. And then I was working with a client. It was a K-12 client, actually. And I saw what they had going on, and I went, stop the presses. I need to use this as an example. So we're going to use that case, and you'll see what we're doing as an example. But I really want to be able to have some time where we can pull situations from the group of you, talk about them, maybe solve some problems for some people, because we got a lot of really smart people in one room right now, and it's not too late where people start hitting the beer. So the answers might actually be good. Well, not to say that they wouldn't be good, but it might be a little more clear right now. And then we'll just have some general Q&A at the end. All right, review. What is DNS? Somebody give me a quick description of DNS. Yes? What's that? Well, yeah, I mean, it helps that we know what it stands for. You know, that's good. Okay, domain name service or server. But what does it do? Translates. Yeah. Human to computer. Right. So we as humans deal with words really, really well. Long strings of numbers we do not deal with very well. I'm sure that there are some people that deal with long strings of numbers, not that, you know, too many. Although if we're talking IPv6, that's a whole nother story. Actually, I have to remind myself. At the Mac World Conference, I had a friend of mine who's a distinguished engineer with Cisco talk about IPv6. And if I thought that DNS might be a little bit of a dry subject, IPv6 makes DNS look like Disney World. But I'll tell you what, he had us all staring at him the entire 2 hours that he talked. It was fascinating. So I'll try to get him here next year, and we can talk about all the IPv6 stuff. But we'll stick with the IPv4 because, yeah, I really can't deal with numbers much beyond this. So this just simply says this fully qualified domain name, which it is, although it doesn't have a dot at the end, it's understood, is equal to that IP address, and vice versa. Now, DNS can be used for more things than just this, but we're going to keep it at this for right now. It can be used for advertising, services, and such, but we're going to stay away from that for this conversation. That in itself could be a whole nother topic. All right. Does everybody get this? I don't want to really harp on this, because I think this we kind of get the idea. That way, you know, this is I want to go to www.apple.com or psu.edu or whatever it is, and it's going to point me. There's going to be a process that goes on. It's going to find where I need to be, and through the IP address, get me to that point and present me with the information that I want. So, good. This is a little different. This is something that many people are not as familiar with. When I first started doing IT work, and even before that, my knowledge of DNS was simply there were 2 slots that I had to put some numbers in. I had absolutely no idea what they were for. All I knew is I could copy it off of the piece of paper that was given to me, and I could put it in where those little slots were, and hopefully everything worked. If it didn't work, I didn't even know what wasn't working. This is actually how DNS happens in the real world. And this is what I find that a lot of IT folks actually aren't that familiar with. What we have here, this was actually stolen from Microsoft, and I did that, I stole it from Microsoft for a reason, but I gave them proper citation, thank you. I can talk about DNS, words just go away. Because if there was ever a company that probably did more to destroy DNS, it was Microsoft. Because they use so many other ways of doing name resolution that so many Windows admins actually weren't familiar with how DNS in its true sense actually worked, because things just worked for them. Because they were using Active Directory, there was NetBEUI and NetBIOS and self-discovery and all that kind of stuff. So I think it's kind of appropriate that Microsoft had a really nice image that they put together that explains how DNS works. All right, so I want to go to www.peachpit.com to buy my book, which wouldn't be so crazy because PeachPit doesn't give us too many of these. It's not me. I am muted. Okay, so if I wanted to go there, how, and I'm tossing it out to everybody because I want to make this a little interactive. How does my browser on my computer or my iPhone or my Android device or my Windows machine, any of those, actually find its way to PeachPit or Apple or Microsoft or Penn State or whomever? What happens? See?
Well, first, it's going to look to your primary local DNS server that's defined on your client, and whatever IP that is, it's going to go, hey, do you know who peachpit.com is? It's going to say, no, I'm not an authoritative for that, so it's going to then send it out to the root server or public-facing DNS server, and then from there, it kind of works down the chain till it finds the authoritative DNS server that is for PeachPit, and then it takes you to the right IP address for that server.
Excellent, very good. I'm sitting down, I'm having my mango smoothie, you can do the rest. Yeah, so let's go through the pieces. So my computer, or whatever other device that's trying to look, because there has been a DNS server that it's supposed to use, defined, it knows to go talk to it to try to get an answer. Now, what DNS server would you typically set up your client devices to use? Probably unfair question. Don't you need to know more about your environment? So let's make a couple of examples. Let's say, because you're an IT person who maybe very specifically deals with handling your backup farm and something else very esoteric, and clustered file systems and compute clusters and everything, you know that your Aunt Gerda is going to call you and say, I can't get on the internet, and you're the one who's going to have to help her. Yes? Yeah. So let's say you go to her house and you're helping her out. What DNS servers are you going to point her to? 8.8.8.8, which is Google servers. But why are you doing that? Absolutely.
And their uptime is really good.
Yeah. It's like it's like I used to use 4.2.2.1, which was, I think, Verizon's. Yeah. But why do we have to use somebody else's DNS server? What DNS servers technically should Gerda be using? The ISPs. So how does her computer know to use the ISPs? DHCP. Is her computer getting DHCP addresses from the ISP? Yeah, you hope not. Right, if she's plugged directly into the router, maybe. Rather inconvenient, but I've seen it done. So how is she getting her DNS if she's not getting DHCP from her ISP?
From the DHCP of her router that's most likely in the house. whether-
Right. So chances are she has a router, and what address is that router probably giving out? Yeah, it's probably giving out its own IP address, 192.168.1.1, which is probably 95% of the addresses for routers in the world. All right. So what that means is so is her router actually a DNS server? No. So what is it doing? It is forwarding, but we have to be careful of the word forwarding because we actually have forwarders in DNS. And depending on the router, it may actually be behaving like a DNS server. Maybe it's running on some sort of Linux microkernel. It actually is acting as a caching DNS server, or it simply could be doing just a redirection. You know, just what's the port that DNS requests come through on? 53, yeah, UDP 53. So it just may simply be saying, all right, I'm your router. I've gotten my IP address from the ISP. I know what the ISP's DNS servers are, and boom, I'm just got anything that comes this way on port 53 is going to be redirected out there because they're the ISP, they provide a router, they can do whatever they want. All right. Already, that's kind of complicated, isn't it? And that's just Aunt Gerda's house. What happens when you've got an entire campus you have to deal with? In a sense, some of it could be exactly the same. In other cases, it could be vastly different. But all right, so we have a device. It itself, a client device, most likely is simply going to look to some DNS server that was provided for it, whether through DHCP or a manual entry of the DNS server, and it is going to do what is known as a recursive query. Now, this is where it gets a little bit confusing because every time that I know that I want to use this slide, and I've used it a bunch of times, somebody will tell me that I have this wrong. And they might even be able to support that with something that they find on the internet. And I will tell you that chances are what you've been looking at on the internet, particularly if it was written by a person just in a blog post or something like that, they probably got it wrong. So the recursive query, breaking it down, making it as simple as possible, it simply says the resolver has made that request. The resolver is in my computer or my iPhone or my tablet or whatever it is. Simply goes, give me the answer to this. And it's going to expect one of two things. One, either the answer, or what's the other possibility? Or the answer doesn't exist. And then that triggers another behavior. But let's talk reality here for a second. Particularly if you are at somebody's house or a small business and not in an environment that you fully control, that you're providing DNS services for, are you going to get an answer or the answer doesn't exist? Is there a third possibility? And if so, what is that third possibility? And I know you've all seen it. Fake DNS in what way?
Redirecting to advertising site or internal publicity from the ISP, or for example, you have also this with for legal usage with OpenDNS when you do sharing filtering and things like that.
Okay, so what we are seeing a lot of nowadays is the ISPs basically hijacking the request. And instead of saying, because I tried to spell Apple with, I don't know, 2 D's in the middle of it for some reason. And there is no www.addle. Probably is. It seems like everything's used up. I should get the answer that says that doesn't exist. But instead, the ISP has hijacked it and said, oh, were you really looking for this? And then they give you a web page with all of the search things with advertisements on the side and such. So right there, the ISPs are breaking the DNS system. They're trying to tell you that they are helping you. And in a lot of cases, that may be right. Like, oh yeah, I meant this. Click and you go, and it's fine. If it is in fact, say your ISP doing it and not some man-in-the-middle attack that's trying to spoof you for some reason. All right, so, why is this a concern? Well, just hold that thought for a while. We'll get back to it. All right, so if we don't have an answer, what most likely will occur, what should occur, is that recursive request from the client to the DNS server that it has been told to talk to, the server, which just says name server up there, turns the request into an iterative request. So what's the definition of that? And what's the difference between a recursive and an iterative? Well, recursive, like I said, theoretically, there should only be one of 2 responses. I have the answer, I don't have the answer. An iterative, it's allowed to only, it can go out and find partial answers. And with the partial answers, put together a full answer. Now, in a lot of cases, I might run an internal DNS server. And the internal DNS server might be authoritative. And what do we mean by authoritative?
You're giving answers for hosts that you control, like I'm example.com, and
Right.
this is www.example.com, and because I'm the domain name server for example.com,
Right.
no one knows most about it.
Right. So an authoritative server is the name server that has the official answers for a particular domain. So in this case, example.com, this is the server that has all the information about example.com, or I could be just running internal for my own, my own organization's use before it even gets to the outside. We'll get back to that also. But okay, so the name server, if it can't talk to yet another name server, which sometimes happens because I may be running my own, and then I may tell it to go look at Google or the ISPs if it's a good ISP, because it might have information that's cached. We'll get back to that in a second. No one said DNS was easy or simple or whatever. Actually, it is, because it's really just name and numbers, and it's just how does it get to them. All right, so in this example, it doesn't have the answer, but it knows to go talk to the root servers. What are the root servers? And who controls them? Okay, the root servers are 13 servers. Actually, it's 13 IP addresses. There are way more than 13 actual servers, because we can't run the entire internet on 13 individual servers. They'd have to be really big. What they control are all of like the top level domains. We've got the root server. Root server says, oh, you're looking for a .com. Okay. All right, .coms are handled by the .com servers. In this case, it actually says gov. So I'll switch over to gov. All right, so the gov server says, oh, you wanted whitehouse.gov. I can give you the answer to that. And then when you finally get to the whitehouse.gov or peachpit.com or apple.com, and you're looking for www, you're looking for mail, you're looking for store, you're looking for whatever the host name is, finally, all that information gets put together by the name server and now gets delivered back to your client device. Seems a little complicated, or at least maybe, wow, that could take a long time. Well, usually it happens in milliseconds, but sometimes if you've got a really busy network or the servers are really busy, or what can happen to DNS servers that is really kind of nasty and has happened. It hasn't happened lately, but it happened a lot a couple of years ago. DDoS. What's DDoS? DDoS is distributed denial of service. So basically, some nasty somewhere decides that they wanted to take down the internet and started to flood the root servers with huge amounts of requests, functionally taking them down. Does anybody remember how many root servers they were actually successful in taking down? It's almost half of them, if I'm not mistaken. That is amazing and absolutely scary as hell all at the same time. What would happen if all the root servers actually were successfully taken down? The internet would cease to exist as a working entity. Because, and this is the little political part of the DNS conversation. If you control DNS, you control the internet. Who controls the internet DNS right now?
Group, education, military.
All of them. Basically, the people who control the root servers, they're the ones who control the internet. And it's basically a group of individuals in an organization that is not run by any one country. A couple of years ago, what was the answer? Because the answer has changed pretty recently. The United States. The United States controlled the internet across the world. How hard would it be to build another internet using the same infrastructure that we have right now? What's that? No. You just have to put up your own DNS servers and convince people to use them. Then you control. Is that going to happen? What's that?
It's what Google do, actually.
Well, yeah. Yeah, it's actually is what Google is doing, but it's also actually what we do within our own organizations all the time. Okay, so we have to understand, if we're going to understand and manage DNS, we need to understand this piece here, because this impacts everything that we do as system administrators, as network architects, as people just trying to solve problems for our users. Why can't they get to the resources they need to get to? If it involves a DNS lookup, which is particularly on the Unix side, almost everything we do sitting at the keyboard or on a touch screen, almost everything ends up being some sort of name lookup. If we don't understand what's going on with this and how all the pieces fit together, it's kind of hard to troubleshoot what's going on. So by knowing this, we can talk about just about everything else. So I just wanted to get this out of the way. So are we comfortable with this, or at least have enough of a working knowledge so we can ask questions later? So it's okay. If you have more curiosity about this, just simply look up recursive versus iterative DNS resolution. Find stuff from companies like Microsoft, Infoblox. Actually, I think it was Infoblox. Infoblox make DNS appliances really, really good, and Cricket Lou works for them. I think it was them. They had a description of how this whole iterative piece works, and the way that they described it was something like you had an old friend that you've lost track of, but you know that your other friend knew them, so you ask them, hey, do you know how to get a hold of Bobby? And John says, no, I don't know how to get a hold of Bobby, but you may want to talk to Mary. I think Mary knows. You talk to Mary, and Mary goes, oh, I haven't talked to them in a long time. Why don't you go talk to Fred? And then you finally talk to Fred, and Fred goes, oh yeah, I got the number right here. So you kind of go through that chain. That's kind of what we've got going on here. All right. What did I do? Here it is. DNS Preparations. How many people here are responsible for DNS in their organizations? Okay. A third to a half, I would say. What are the questions that you ask yourself when you're dealing with your DNS in your organizations? What's important to think about? Okay, what zone to put it in? So what does that mean? Okay, so I used to have a slide that actually broke down a fully qualified domain name and what each piece was. Host name, domain name, top level. Top level would be like .com. The domain name would be like Apple. And the host name would be, say, store or support or, you know, whatever it would be. So when you're putting together DNS, you have to think about, well, how do I classify my resources so my clients can get to them? Yeah, organizational unit. What makes sense? Do I put things as host names? Do I not? Do I have subdomains? What do I do? Subdomain would be a domain of a domain or domain within a domain. But kind of the first question that we have to ask is, where are the clients? Where are the servers? So what does that mean? How many people here have to deal with clients only within your organization, within your network? Okay, one. If this was 5 to 7 years ago, probably most of you would have your hands up. So where are you dealing with clients nowadays? That the answer is not just strictly within your network. External services. Is that what you're going to say? Yeah, I saw your hands like, yeah, they're all over the place. I mean, what's the biggest change that we've had in IT over the past few years? Mobility. And mobility just isn't phones and tablets, but simply, I mean, how many people here have organizations where people walk in, they sit at their desk, and they probably have their Dell or something with a little 15-inch LCD display, and they log in with their AD credential, and they work at that all day, and then they close it at night, and then they go home, and that's the only interaction they have with their data. You guys are laughing because that's not IT anymore. That's what it was 5 years ago, 7 years ago, 10 years ago. People went home, they didn't deal with it anymore. Now they've got phones, they've got tablets, they've got their laptop, and they expect to be able to get to their resources pretty much wherever they're at, right? Does anybody not have to deal with that? I mean, it's possible depending on what your environment is, but for the most part now, people just need to get to their stuff no matter where they're at. So we have to think about where are they and where are the servers that are going to have the information so they can get to it. How many people here manage their own external DNS server? Okay. Okay, publicly facing. Okay, now for the people who manage their own publicly facing DNS server, do you let anyone use it if they know that figure out its IP address? Okay. And I gotta say, it's like we've got, I don't know, 40 minutes left. I'm more than willing to answer any questions after the fact, if we don't get a chance to talk to it now. That's a really good question. If they figured out that you have a DNS server out in the network, they saw their friend who works for the organization that you're in or is a student or whatever, and they copy down the IP address and they put it in, they start using it. How do you prevent them from doing it? Simple answer is you really isn't. Right. So,
Is there an alternative though? I mean, you can have all of your services that need to be accessible from anywhere in the world, public facing just by a public DNS record through your domain registrar.
yes.
You don't need to actually have your own DNS server, you just do it through your registrar.
Absolutely. So there is a way, and we'll talk about that very shortly. We're getting right to that point, where if you're not hosting your own servers out there, you can just make the information that's required for your clients available through hosted DNS services. But if you are hosting your own for some reason, you have to start thinking about what kind of server is this going to be? Is it just simply going to be the start of authority, the SOA? How many people have seen that in a DNS record, SOA? How many people went, the heck does SOA stand for? I know I did for a very long time. The start of authority is basically saying, hi, I am the server that is authoritative for Jehoshaphat.com. And with that, any requests that may find their way down, I don't want to flip back to the other slide, but that server was found because somebody needs to go to store.jehoshaphat.com, they'll be able to find it. But your authoritative server is not the one that's being used for general purpose lookups. It's really only going to be there to answer questions about that one domain. So that's something to consider. All right. Yeah. Ooh, let's ask the people who have done it. Okay, simplicity in some regards, fewer things to manage. In what way? You don't have to, I'm sorry.
Need your records in fewer places. If you're splitting it, then you've got to clear internal records and your external records, and you have to keep track of them and make sure you're updating both.
Right. So it just might be a situation where you'll want to basically have one screen to manage everything. So I'm just going to manage my internals, my externals. It's on the same box. Everything is good. Other reasons?
You might want to have an internal DNS server that resolves all the internal things that are just private to you. If you have some external services, you don't want somebody who uses your external DNS server to be able to query it, get your internal, data, and then have a map in your vulnerable systems when they come out of attack.
Right, that's a security thing. We will be talking security. Okay, very good answer. So if I am, and I'll use Apple as an example, internally, Apple probably has all their printers available and internal access to file servers and stuff like that. But if you want to go to the website or the mail, chances are that kind of query could come from either inside or outside, and you need to be able to answer it from either location, which goes to our question: where are the clients, where are our servers? So we could have two full sets of servers. We could have individual servers that will answer differently whether the request is coming from inside the network or outside the network. Does anybody know? I might give away a book for this one. Who knows what the process is in Bind to define different answers based on where the request is coming from? What's that? Views, yes. You get a book. You guys hand this back to him? Yeah, views are kind of interesting because it does allow you to have different answers based on where it comes from. And sometimes that could be internal requests from inside your LAN versus the external requests from outside your LAN. But can you think of any other situations where you might want to answer differently based on the requesting IP address? Right, but what about could you use views even internal to your own environment? What's that? Load distribution. You might have an organization that's worldwide, and certain resources like, say, directory services, although there's different ways of handling directory services, but if a request comes in from your Singapore office, you might want to send it to resources in the Singapore office rather than sending it across links to someplace else. So you can use views within it. How many people here use OS X Server to provide DNS? One. Okay.
That's 10 years ago.
Yeah, once again, so many things that we're talking here, you know, it's like the answer today is different than what it was 2 years ago, which is different than it was 5 and back. Because probably if this was a few years ago, I'm not going to say everybody's hands would have come up, but a lot of people would have put their hands up. And how many people here used to use a lot of OS X Server? How many people are no longer using a lot of OS X Server? Yeah, even more hands go up. I don't want to say it's kind of a shame, but actually what we have now from Apple with OS X Server, if I can just get up on my soapbox a little bit, it's still a very good system. You just have to look at it maybe a little bit differently and consider it more of an appliance than just a general overall, I'm going to run my entire organization off of it. Although you could if you really wanted to. That hasn't changed. We just have so many other tools that are kind of better. So, and that's come from the guy who wrote the book. I actually love it because...
Plus they don't make server hardware anymore.
Yeah, but you know what? Most of the things that I'm using OS X Server for, it's the service that's redundant. I don't care about the server itself, except for Profile Manager, which is still, that's a little bit of an issue. But DNS, DHCP, VPN, all that kind of stuff, you know, if my redundancy could be 2 Mac Minis, 3 Mac Minis, 10 Mac Minis. If I'm running caching server, I mean, holy cow, you can get a $500 server, hang a bunch of storage off of it, 19 bucks, fire up a caching server, and that's awesome. I mean, even VPN, you know, you can get away with a $500 Mac Mini, $19 for the software, and unlimited VPN clients. You know, go to Cisco, find out how many, what's that going to cost you? All right, we're getting off track here. Sorry. All right, I meant to flip this up a little bit earlier. This was talking about the internal, external stuff. I'm adding a new section here, DNS Security. How many people here saw this last year here? Anybody? Okay, one person. And Jared was here a little bit earlier, but he left. Okay. I'm going to, once again, get on my soapbox for a moment. Because how important, well, I'm going to ask a question first, then I'll jump up on my soapbox. How important is DNS security? Well, Ben, that's a very vague question. Well, all right, does anybody have a thought on that?
Well, it's very easy to orchestrate man-in-the-middle attacks if you compromise DNS. Any link of chain.
Right. So this is what, when I decided, you know what, I should put something in about DNS security. And I kind of have my own thoughts on it. But I started looking at what was published out there on DNS security. And it kind of fell into 2 areas. One was, well, this is what we're working on, but still hasn't actually been implemented. Or, I sell this, and it's really secure. Well, what does that mean? Well, a lot of times, the security that they advertise is really kind of for esoteric attacks. Why is DNS security important? DNS security is important because we want to know that our clients are getting the information and are being pointed to the place we expect them to be pointed to. So you mentioned man-in-the-middle attack. What exactly is a man-in-the-middle attack? Well, this is a case where I can jump on a network, and for some reason I have to do some banking. So I put in, you know, www.chase.com or whatever, and I get to a website. Looks like my Chase website. I put in my username and password, kind of goofs around for a little bit. Next thing I know, I'm asked to put in my username and password again. And it goes crazy again for a moment. And I put it in a third time. Also, no, great, I'm into my bank. And I do whatever it is that I need. What do you think just happened to me? Bad things, compromise. How was it done?
Redirected you a site that was not chase.com, but through DNS cache poisoning or whatever, and you put your credentials in, they get your credentials, they keep those credentials.
Mm-hmm.
If they're good enough, they then redirect to the actual website, so you do eventually get there and
Right.
you log in, so you think that everything's okay. They now have your credentials and go in there and drain your bank account.
Right. So they were really smart. They did two things. They checked my password twice. Because guess what? I could have screwed it up the first time. But they checked it twice. Now it matches. Now that it matches, they flip their code so it actually forwards me to where I expect to be, and I don't think anything of it. Because I get to where I think I'm supposed to be. So, let me see something. All right. I'm going to hold off the man in the middle part for a moment. If you are hosting your own DNS server and you're within your own network, one thing that people used to make a big deal about was making sure that you would not allow zone transfers. What's a zone transfer? Zone transfer is when another DNS server can talk to your DNS server and say, give me all your records. Now, if you're hosting multiple DNS servers, let's say you've got a very large organization. You've got, 20 of them around the world or around the country or in your state or one in each office or whatever it is. Do you want to go and have to manage each and every DNS server? Do you even want to manage two of them?
One single point of entry.
Single point of entry. Give it a chance, give yourself a chance to make the mistake once, correct it in one place, and then it just all goes out to all your other DNS servers. So your DNS servers, which are set up with secondary zones, will go and talk to your primary zone and go, give me all your information. And it replicates over to the other servers. Now, what was a real concern in the past, probably still is a little bit now, but things have changed. What people were afraid of is that people would gain access to your network, do a replication of the data that's in all your zone information, and then be able to derive information from it. Ooh. These are all of the printers. I can see printer names here. Printer, third floor. Color printer, third floor. Broken color printer, third floor. And, they can figure out that, some smart IT manager figured out, okay, we're going to put all those on 172.16.3. But then they're looking and they're going, FileMaker server, files. Really important files. Really, really, really important files. And they're all at 172.16.4. If you were a bad guy and you really wanted to maybe kind of poke around a little bit, are you going to 172.16.3 or .4? Yeah, you're going to go to probably the really interesting subnet or VLAN or however they have it split up and start pinging and poking and doing attacks on a very narrow range of IPs. Are we really worried about that as much now? Probably not as much because we've got better intrusion systems. Anybody here familiar with how OS X server deals with brute force attacks? This will be good for a book. Good for a book. Yes. So at the first time that there's an error, there's a little delay before it allows you to check again. A little more of a delay the third time, more and more and more, till it gets up to minutes. And eventually it will shut it down. It's basically part of the firewall, the application firewalls, all that type of stuff. So you had the concept, get a book. Okay, hand that back. All right, so we have other ways of dealing with that type of stuff now, but it's probably still a good idea to limit your zone transfers only to known DNS servers. And that can all be set up in bind, which is probably chapter 4 in the Cricket Lou book. I think it is, actually. All right. All right. Oh, yeah. Only allow requests from known networks. And that's kind of basic, just network management. You're not going to let somebody from the outside try to get resources on the inside. But let's get some really interesting stuff now. DNS disasters. Has anybody here had to deal with a DNS disaster? Come on, everybody has had to do it. You just may not have known it. What disaster did you have? If you're willing to share. Ooh, okay. So just things weren't being answered the way that they're supposed to be answered. And ooh, ouch. All right. So this is, well, the actual IP addresses have been changed to protect the guilty, but this is what I saw when I went to a client 2 weeks ago. Soak this in for a moment. I promise you this is 100% real. It was an OS X server. It offered Open Directory. It offered file system, or file services, Kerberos, single sign-on. And it was used by client devices, computers. Apple has got me so in the mindset everything's a device nowadays. It provided network homes. It was a lab at a school, and kids would come in and sign in with their credentials. All right, so I'll flip back and forth on this. This was basically how things were set up. So we had the regular district network. Then you had, for the lab, the computer, the server, that also offered DNS and DHCP. I meant to make those white. I apologize, they didn't show up that well. But we also had DHCP and DNS on the regular network. Is that a problem? Well, is it a problem that there are two servers providing the same services?
They're on the same network, same VLAN, so they're hosting out things.
Right, so the answer is probably. But it depends, because it might be set up. Maybe these are on separate subnets. Maybe there's a switch in the middle, which there wasn't. You know, that transferred. Right, I mean, you know, maybe one was serving DHCP in this range, and the other one was sitting on that range for whatever reason. You wouldn't necessarily do that, but it could. DNS for the same thing. One could be referring to the other one. It wasn't. It wasn't.
They were independent of one, they were set up as independent of one another, not
Yes. They were providing different DHCP information that contained different information, that contained wrong information. If I go back, so let's break this down, because this is the kind of stuff you'll really run into. So IP address, fine. Subnet, okay. Typically, you wouldn't find a /16 with a 192.168, but that's just sort of best practice. It's not really wrong anymore. But take a look at the line of the DNS. What do we have going on there? This is what I saw on a client machine. This is what was showing up on a client. Yes.
Was it running a DNS server?
No.
Was it exactly 20.5?
Well, no, its IP address was .12.
One is, yeah, the DNS is like you got localhost,
Uh-huh.
something that may or may not be routable, and Google, but if,
Yeah. Thus, that was me. I mean, literally, I mean, I've been in this business since '99. I've seen a lot of disastrous stuff. I've created a lot of disastrous stuff. You know, I've screwed up my own stuff really, really well. I've screwed up other stuff. I fixed it. But this was the first time I think that my jaw really hit the table.
But did this just break for them, or had things been screwy for a long period of time?
Here's the thing, it worked. It worked. They were able to log in to their network accounts, get their network-based home directories, and it worked. See you later. No. So this is what happened. When I first saw this, and then I started doing, does anybody know what tool is handy on OS 10 to try to figure out where your DHCP is coming from? IPfig, get packet, and then the whatever port. Yeah, EN0, EN1, whatever it is. And it makes sense. And it will actually tell you what IP address you got, where it came from. It's really, it's a good tool. And I realized that, all right, I'm getting it from this DNS DHCP server, the lab server, but why is it running this? And why is the lab server getting its information via DHCP? But they did have a statically set, or excuse me, it was DHCP with a manual IP address for the server. Then I started doing some lookups and discovered that, in fact, the server had a DNS record in the regular network DNS server. So I did an experiment. So I turned off DHCP on the lab network, and lo and behold, the lab clients were starting to grab IP addresses from the regular network. So we lucked out. The regular network DHCP was, I'm not going to say it was perfect, but it was less screwed up than the lab server. We rebuilt the lab server. By a miracle, there was actually a usable DNS record in the school's DNS records that I was able to use, and actually it was the Mac Server 2. Go figure. And there was a forward and a reverse, so that's the IP address that I used, and the host name that I used for the Mac server. Set the whole thing up, forward reverse, got Kerberos working, all that kind of stuff. Forgot about both DNS and DHCP on that server, and it cleared everything up, and it wasn't going to break because, well, we haven't answered the question because you're looking at me and you're going, but how did it work before? Is DNS the only way for an OS 10 computer to get name resolution? No host files. Good guess, though. Host file is literally a text file that has lookup information in it. Yeah, Bonjour, or Rendezvous, or MDNS, or ZeroConf, or whatever it's being called at this particular moment. So, all right, this one's really obscure for a book. Who knows why, and name names, why Apple needed to switch from using Rendezvous to another name for the ZeroConf. What's that? Buick? No, that would have been an even better story. But actually, it's sort of related to that. You said that it was trademarked? Yes. The name was, in fact, trademarked by somebody else. That somebody else was a company called Tibco, Tibco was a financial services firm that had software called Rendezvous, which just happened to work, or a feature of it worked kind of similarly to the way that Rendezvous that we know it worked, and they were able to get Apple to stop using it. So that's why it switched. So, good enough. Let's hand it back. Steve. All right. So it worked because the file server was advertised via Bonjour, and the client machines, probably after they tried like 5 times to actually log into it, finally was able to get the right DNS, was able to correlate everything with the Bonjour, and everything. Once everything worked, everything was kind of cached, and life was good for them. But once we cleared up everything and put it the way that it was supposed to be put, things started working much, much better. Logins were, I mean, they were really, at the school, they were surprised because the logins were taking like, 15 seconds. And they were used to like minute and a half. But they worked. They actually worked. So it's just scary when you see something so broken, and yet it does work. All right.
So do you have to blame somebody specifically for the screw up, or?
It doesn't matter. Well, actually, there was one person who kind of did it, but they weren't there, so.
Oh, all right.
And for me, I got it to work. They signed my paperwork. I was out of there. Everybody's happy. All right, this is where it really gets fun. And we'll fill in details as we go along. Who here has a DNS issue that they wish to discuss? Maybe get some answers. That's the universal sign of, where do I start? Is that working now? It didn't work at the last. All right. Speak into the box.
Testing. Oh, fantastic. Everyone's going to hear this. So the other day, like a colleague of mine and I were monitoring network traffic on her production machine, joined to a public Wi-Fi outside of our organization without
Okay.
VPN on. We noticed authentication traffic going towards the, I guess, the domain controller.
Okay.
And of course, it wasn't able to resolve to the
Yes.
internal address.
Right.
So I guess my question there is, I'm actively exploring this and kind of wondering how that works. Like, what if, for example, because like my domain controller is like dc1.organization.internal, is there any case where it might get rerouted to dc1.com if it can't find, .internal?
Okay, so the question is, so your AD environment, sounds like,
Yeah.
you had a device that connected to an outside network. It tried to authenticate itself.
Mm-hmm.
So it did a lookup for, what's your domain?
The internal. So it did a lookup for the DC controller.
Right, but it was dc1 dot,
pretendco.internal.
pretendco.internal. Okay. Not .local.
No, .internal.
Okay. So that's all right. So it's interesting. There was some information out there from a few years back where the root servers almost, I think it was, once again, about a third to a half of their requests were all coming for .local accounts. So I was just curious if it was that. All right. So this goes back to, if the DNS server that it's talking to doesn't know what to do with, or it doesn't have the answer, it doesn't know where to route it, it starts doing that top-down, start at the top level domain, root server, and then it will point it to the, .coms, .edus, and it's probably going to try to find a .internal and not find it, and technically it should kind of hang there, but you can't stop the request from happening. Now, there's a lot of places that use, like, organization.org, both internally and externally. And their domain will be organization.org, which is completely legitimate even on the outside. And sure enough, a device that's on an outside network it gets an answer for organization.org, but it will hang because you probably don't have your domain controllers
Yeah.
cleared through to the outside world. So it will actually get an answer for domain.org or organization.org, but that's as far as it will go, and then it will hang, and either it will time out or it just won't be able to do anything depending on how it's configured. So short answer is, can you prevent the lookup from happening? No, at least not easily. But the question is, was it causing a problem? Or are you concerned that it's going to find its way back into your network?
Well, I considered that there may be a possibility that if an attacker were to register, for example, dc1.com, they may be getting a lot of authentication traffic as a result.
So if they wanted to do kind of a man in the middle, if they were really clever, if they had some real specific goal in mind, and they know who your people are, possibly they could set up a situation where they could do a man in the middle. I don't know exactly how you would protect against it, because that would take some work on their part to be at the right place at the right time, to join the right network, to trap the request that's coming through specifically for your organization.internal domain. They'd actually have to capture that request and provide a DNS answer for it that directs to something they control to try to get the information. It would still probably fail because all of the password stuff would be tokenized, and they probably wouldn't be able to do anything with it.
And basically you have Kerberos behind.
What's that?
You have Kerberos behind.
Kerberos?
It's AD based, so you have Kerberos behind, so you will never leak your password.
And also, our AD domain is not internal, so you would never be able to buy the .internal
Yeah. Well,
notification thing. So
Well,
if you have a fake DNS on the server,
bogus, whatever, if it doesn't exist, it's not a legitimate powerful domain. The request is going to go out.
from an attacker point of view, it's not a problem.
Yeah, I was just saying, like,
Yeah.
the whole, like, dc1.com thing, like, where did that come from? It could be somebody stood up their own,
Fake
fake
DNS.
DNS at that, whatever's using that, doing that revenue public Wi-Fi, and it's just buggy.
Mhm.
And saw .kernel didn't know what to do, and just said, I'm gonna take the first thing, .com.
Yeah, that's the idea. And from there you have a dragnet, because, right, so.
Yeah, if
Yeah.
somebody found that, like, somebody in the room, and stood that domain up, they could probably say, I'm gonna eat everybody's Starbucks traffic.
right. So, and that's the issue. If you control the DHCP that a client gets, you can start controlling their DNS. You can start controlling a lot of things. So you want to be aware. And that's why in the picture of the network I put up there, basically they were doing their own man in the middle, in their own organization. I meant to say that before, so thanks for reminding me on that.
The DHCP though, isn't that coming from like the IP helper address on the switches? So how would you jump in?
There was no helper address. It was one flat network.
Okay,
So the crazy thing was, just not were they set this up with the thought that, well, since my server in the lab is going to the same switch that all my client devices are, that's going to handle the DHCP. Well, the reality was, the clients are just going to put out a DHCP request, and whichever DHCP responds first, that's what it's going to pick. So it could have picked that one, it could have picked their other one. At the same time, since this was just being dumped on their network, guess what? All the other hundreds and hundreds and hundreds, maybe thousands of machines, could have been getting answers from the lab DHCP server.
absolutely.
And they probably had no idea why things were going wrong.
Anything that's routable based on the subnet mask could have all gotten there.
Yep, exactly. So that's why it's critical to know how your clients are getting their DNS information. So you might say, from a security standpoint, I'm just going to hard code the DNS servers on each one of my machines. If you're in charge of 10,000 machines, well, how many machines do you have at MKA now?
1400?
1,400? Would you even want to do that on 14?
No.
Yeah. So DHCP is still a really good thing. what can you do to protect against somebody dumping an extra DHCP server on your network?
DHCP snooping.
Yeah, you should have network monitoring turned on your network. Who was at the security thing with Dan Griggs earlier today? Basically, he said was security never stops. You're always monitoring, monitoring, monitoring. And that's kind of the mindset that we need to get into. You know, am I seeing port 53 requests being answered by some server that I'm not expecting? Am I seeing DHCP requests being answered by a server I'm not expecting? Are there port 53 requests coming from areas that I'm not expecting? So, okay. We have a short amount of time. Next question, next disaster, next situation.
I'm sorry. So your opinion or take on split horizon or split DNS versus, you know, NAT and all those different options. You know, what's your optimal setup?
All right. So the question is, you know, do I have an opinion or a preference on split horizon versus NAT or anything like that? Can you give me a more specific example, because it's kind of broad?
Yeah. I don't know how specific I can get. I'm sorry, my scenario. This is actually just something I went through last year, so
Okay.
I'm just kind of wondering what you would have done, I guess. But setting up a new environment, new domain, basically, you know, from scratch, DNS, all that. You know, you have to answer the question of, are we going to do internal, you know, publicly facing DNS? Are we going to do split DNS? We're going to have a subdomain for our domain of our public
Okay.
domain, you know. Like,
Okay. So the question is, if I'm setting up a new environment, what are my preferences really for all this kind of stuff? So these are my preferences, and I'm not going to say that they're right for every single situation. My view is, if I can get away with it, I am going to use a hosted external DNS for external requests. Why? Because let them worry about DDoS attacks. Let them worry about uptime. I'll just go and I'll put my information for my domains into my registrar or my hosted DNS. I'm just going to let them worry about it. There are companies out there that can handle any size organization on the face of the planet. You know, even if I have an organization with 250,000 people in it, and I've got tons and tons of resources that I need to put records in, there are companies out there that can easily handle that. I'm a big fan of hosted services for stuff like that. It is less of a concern for me to keep those servers up and running. My second level choice would be, I will stand up, if I absolutely positively have to handle my own domain on the outside world, I will set up my start of authority. Hopefully no one really gets the IP address of that. Well, it's going to be out there because it's going to be part of the record, but most people are not going to use it. But that's the only thing that box is going to do, or a series of boxes. I don't want it to, you know, be in a position where I lose that device and now no one can get to my resources. No one can send me emails, no one can get to my website, stuff like that. So I'm going to have, you know, redundant servers, but I'm still on the outside. I want somebody else to handle that for me. Inside, I'm all about your own DNS servers. But you have to put the resources in terms of people power to make sure that they're running, make sure that they're right, make sure that they're available. But I like having control inside because you can do so much with DNS and putting records in for everything and really make it a better, better exposure for your users. So, and at that, it flashed down to 0. I'm not going anywhere, at least until they kick me out. I am here to answer any other questions you have, and I will be more than happy to answer them for you. Thank you.